how to do these lab and to help you guys with some of the questions that you're developing. First of all, when you get to the bumps part where you have to make the track, what I've been noticing on people's things is they're not setting it up correctly. So this is point E and this is point G. And these are the two that have to be exactly the same height. To make sure that's true, when you click on the dot, you should be able to see those little dots in there, and that tiny little gray circle that's at the very center, put that right on a grid mark. So then you know that's the height. And then when you set E, again, you want that one circle that's at the very center of the larger gray circle to be right at that grid mark. That will ensure that both this dot and this dot are the same. Because what I have been seeing is like you have it like just a slightly bit lower and it kind of looks like it's the same height, but it's not. It's very important that they are exactly the same height. And that should really lead you to the explanation of what's going on with that question when you're comparing the speed here versus here. So let's talk about the beginning of what's going on here. So at this very top point, point A, this is where we start. Where we start the car determines how much mechanical energy we have in our system. If I were to lift this dot up way higher, can you see how the total mechanical energy increases and the total potential energy increases as well? So if I start this, again, I'm putting my dot on this line right here, this defines how much total energy I have. So this, if I were to kind of make a little dotted line go across right here, this means anything above this line is forbidden. It's going to violate conservation of energy. So when we talk about point F, I can't get there because I didn't start out with that amount of energy. So we want you to try to explain that in your own words. All right, so the next question deals with comparing this point and this point. So to collect data, you need to do a screenshot. You need to show me the data. It wants you to compare the speed. So if I want to compare speeds, well, if I have data on kinetic and potential energy, I really want to compare the kinetic energies, because if my two dots have the same kinetic energy, then they must have the same speed. So you want to look at this data. So start the run, and when you get close to the point that you're interested in, hit the step button and just step it through, step it through, step it through until you get to the very top of the bump. So right about there, maybe a little bit over, but that's pretty close enough. Screenshot this, okay? And then start it again and get to point point G. And again, I'm going to use the step function, step function, step function, step function, step function. There we go, there we go, there we go. And screenshot it. And then make your comparison about the kinetic energy and then explain why that these kinetic energies are what they are. Talk about the total energy. Talk about the fact that you know that they are at the same height. What does that mean if they're at the same height in terms of energy? Which energy depends on the height? So that is enough clues, I think, to help you with question number 4. All right, the last question is that people are struggling with is the question with Mac and Tosh. So Mac and Tosh have the two explanations saying at this point, point F, Mac says the reason why it's the fastest here, and again, you can see that if I hit my play button and I can see that it's going to reach its maximum kinetic energy there, you can see that that's when that's happening, right here at the lowest possible point. And we can talk about how that energy gets transferred. Mac says it happens because it's the furthest along the track. But Tosh says it happens because that's just happens to be the lowest possible point. So to prove Mac and Tosh's arguments and to disprove Mac, you have to make this point happen earlier and see what happens. Again, take a screenshot of your bar graphs here. Don't change anything else, but this is your point F. You can put it here, or I can take this one and maybe bring this one down to the same height. So if Mac was correct, he would say that this is going to have less speed than over here because this one happens later. So that's one way that you can analyze that system. And I hope, and again, I'm looking for explanations that make sense. Talk about the energy, talk about what you know about the height of the coaster and how that affects the potential and the kinetic energy. Talk about what you know about this total energy line being the sum of those two. So I'm hoping that this quick tutorial will help you to give full, rich, claim evidence reasoning explanations, which is really going to help you for next year when you have to do this for a biology class or a chemistry class or an earth science class. Claim evidence reasoning.